Welcome back, everybody, for another deep dive. Looks like you've given us quite the reading list this time.
Yeah, we've got Neil deGrasse Tyson's Merlin's Tour of the Universe.
So it seems like you're ready to tackle some truly cosmic questions.
Well, this book's format is really cool and engaging.
Yeah,
It's like you're having a one-on-one with Merlin, a fictional visitor
right.
from the Andromeda Galaxy, no less, who answers reader questions about, well, pretty much anything space-related.
I like it. It really makes you feel like you're sitting down with, some sort of expert and picking their brain about the universe.
For sure.
And speaking of questions, there are some seriously mind-bending questions in here, like what happens if the Earth just suddenly stops spinning?
Ooh, that's a good word.
Or could you, escape into space with just the right outfit? Why in the world does Saturn float? What's really happening when a star twinkles?
I love that question.
And are there other Earth-like planets out there?
Well, we've got plenty to unpack here. To start our cosmic journey, why don't we focus on our own little corner of the universe first?
Okay.
Earth and the moon.
Speaking of Earth, I've always wondered what would happen to, the oceans? If Earth suddenly stopped rotating, would they just, slosh to one side?
So picture this.
Mm.
You're cruising along with the Earth's rotation
Right.
at about 1,000 miles per hour eastward,
Wow.
and then suddenly everything slams to a halt.
Yikes.
And it wouldn't be some gentle slosh. It would be more like a massive tidal wave, like just sweeping across the globe.
Oh my gosh.
As the oceans, just because of inertia, keep moving eastward,
Wow.
coastlines would be, yeah, they wouldn't stand a chance.
Oh man, that paints a pretty dramatic picture. But didn't I read somewhere that Earth's rotation is actually slowing down bit by bit?
Yeah, it's a super gradual process
Hmm.
happening over eons, really.
Wow.
It takes, get this, 67,000 years
Wow.
for our day to get just 1 second longer.
That's wild.
So you can thank the moon's gravitational pull for this kind of cosmic braking effect.
Oh.
Creates friction against Earth's rotation.
It's amazing how these celestial objects have so much, influence on each other. Speaking of the moon, I was surprised to learn that it looks 50 times brighter from the lunar surface than a full Earth does from here.
Right.
You'd think it would be the other way around, wouldn't you?
Yeah, it seems counterintuitive at first.
Yeah.
But think about it. The Earth is much larger than the moon
Right.
and reflects a lot more sunlight.
Oh, okay.
So if you were standing on the moon, Earth would be this massive, brilliant orb just dominating the sky.
Okay, that's definitely going on my space travel bucket list. But
Yeah.
while we're talking about the moon, can we debunk a myth about, blue moons? I always heard they were, incredibly rare and only happened in February.
This book actually sets the record straight on that one.
Okay.
A blue moon is simply the second full moon that occurs within a single calendar month.
Ooh.
It's kind of just a quirk of our calendar system.
Huh.
Happens every few years, definitely not just in February.
So not quite as rare as we're led to believe, huh? This book is full of, these little fascinating insights. Did you know there's a reason why we can sometimes see, the unlit part of the moon? They call it Earthshine.
Oh yeah, Earthshine is a pretty subtle but really beautiful phenomenon.
Yeah.
Yeah, it's sunlight reflecting off Earth's surface that then illuminates the darker portion of the moon.
Oh, cool.
Makes it just faintly visible to us.
So it's like the moon is reflecting Earth's reflection back at us.
Exactly. Like a reminder, kind of a poetic one, of how interconnected our celestial neighborhood is.
I love that. And speaking of reflections, one last moon mystery for you. Why is the Sea of Tranquility, where Apollo 11 landed,
Right.
so flat? Isn't it supposed to be, a sea?
Kind of a misleading name.
Right?
The Sea of Tranquility, it's actually a vast, solidified lava flow
What?
formed billions of years
Oh,
ago.
I'm not not a sea at all.
Nope, a glimpse into the moon's fiery past.
Oh, that's cool. So from a constantly slowing Earth to an ancient lunar lava flow disguised as a sea, this cosmic tour is already full of surprises.
What do you say we venture beyond Earth's orbit now?
Absolutely. Let's blast off to our planetary neighbors.
Okay.
I think you'll be particularly interested in one that could float in water.
Okay, now you've got me intrigued. But before we dive into all those details, wouldn't it be helpful to just, remind ourselves of the order of the planets?
Yeah, totally.
Remember that mnemonic, my very educated mother?
Just served us nachos.
Oh, yeah, that's right.
Classic. Helpful for remembering the order.
Yeah.
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And each planet is so incredibly unique.
Speaking of unique, did you know that Saturn with its majestic rings, is actually less dense than water.
Is that wild?
Yeah, like it would actually float.
Exactly. Saturn is a gas giant composed mostly of hydrogen and helium, which makes it super light for its size.
So if we had a bathtub big enough,
We could watch a planet do a cosmic backstroke. I love that image. And speaking of Saturn's rings, I was always curious, how thin are they really?
okay, so imagine a sheet of paper
Yeah.
stretched across the entire diameter of Saturn.
Ooh, okay.
That's how thin they are.
What?
Yeah. No wonder they practically vanish when seen edge-on from Earth.
That's crazy. Okay, for our next planetary pit stop, let's visit a neighbor a bit closer to home,
Okay.
Venus. Often called Earth's sister planet, right?
Well, not quite a sister, really.
Yeah.
I mean, Venus might be similar in size and gravity,
Right.
but the resemblance kind of ends there.
Oh, okay.
Venus has this runaway greenhouse effect.
Oh, yeah.
It's wild.
Yeah.
Its thick atmosphere traps heat like a pressure cooker,
Oh, wow.
resulting in surface temperatures that are hot enough to melt lead.
So Venus is less of a sister planet and more like a cautionary tale about what can happen when a planet's atmosphere goes haywire.
Yeah, I think that's a good way to put it. Venus serves as a stark reminder of how delicate a planet's climate balance can be.
Right. Okay, well, from a planet that's too hot to handle, let's shift our focus to some other celestial objects
Okay, sounds good.
that streak across our skies.
Oh, you mean like comets and meteors?
Yes, exactly. The book describes this incredible sighting of a bolide meteor.
Oh,
I
yeah.
always wanted to see one of those.
Bolides are like cosmic fireworks, incredibly bright meteors that often explode in the atmosphere,
Oh, wow.
leaving these glowing trails of debris.
Like the book mentions that they're like the rock stars of the meteor world.
Yeah.
So tell me more about this sighting that they describe.
Okay, so picture this. You're outside on a clear night,
Okay.
gazing up at the stars, and then suddenly this brilliant streak of light appears,
Oh, wow.
illuminating the entire sky for just a few fleeting moments.
Hmm.
And then it breaks apart into smaller, fiery pieces, each leaving a luminous trail before fading out.
Oh, wow. Okay, I'm adding Witness a Bolide Meteor to my cosmic bucket list right now. That sounds amazing. And while we're on the topic of things that light up the night sky, let's talk about why stars twinkle.
It's not magic, although it seems like it.
Right.
It's Earth's atmosphere kind of bending and refracting the starlight
Oh.
as it passes through the different layers of air.
Oh, I see.
So the star's apparent position seems to jiggle,
Right.
which we perceive as twinkling.
So it's like our atmosphere is playing a cosmic game of hide and seek with the starlight.
Exactly. And here's a fun fact. Planets, unlike stars, usually don't twinkle.
Oh, really?
They appear as tiny disks of light rather than pinpoints.
Huh.
So the atmospheric distortion is less noticeable.
So next time looking up at the night sky, if it's a steady light, it's a planet.
You got it.
Okay, good to know. Now, from twinkling stars, let's move on to those, familiar patterns in the sky.
The constellation.
Yes. Constellations. I've always wondered, who decided what those star patterns look like and, what they represent.
Yeah, it's this fascinating blend of ancient cultures.
Yeah.
And as the book humorously points out, some rather imaginative minds.
Right.
A lot of our constellation names and stories actually come from the ancient Greeks, Babylonians, and Egyptians who saw gods, heroes, and mythical creatures in the stars.
It's amazing how those, ancient interpretations have persisted, for centuries.
Yeah.
And from those, familiar patterns in our night sky, I'm ready to take a giant leap outward
Okay.
to the Milky Way and beyond.
Buckle up. We're about to shift our perspective to a truly cosmic scale.
Okay.
We'll be talking about galaxies, black holes,
Ooh.
and even the mind-bending concept of time travel.
Sounds good to me. Let's blast off.
All right. Welcome back.
All right, so we were just about to take a cosmic leap out to the Milky Way.
Yes, we were.
And I, for one, am picturing our galaxy as this giant, cosmic pancake made of billions of stars.
Right, like I was describing earlier.
Yeah, exactly.
Yeah, that's not a bad way to visualize it at all.
Okay, good.
And just like we only see like a cross-section of a pancake, from the side.
Right.
We see the Milky Way as this band of light stretching across the night sky because we're, inside the disk, looking out.
Right.
It's kind of mind-boggling to think that each point of light in that band is a distant sun, potentially with its own planetary system.
It really puts our place in the universe into perspective.
For sure.
It's almost humbling to think about how vast and grand everything is.
Totally.
And then get this, The book says that our Milky Way is just one of trillions of galaxies in the observable universe.
Trillions is just like a number that's hard to even grasp.
It really is.
It makes you realize that we're just a tiny, tiny speck in a cosmic ocean of galaxies.
Yeah.
And some of these galaxies are like absolute giants.
Right.
There's this galaxy, I think it was discovered pretty recently, called Alcyonius. Yeah, it's a radio galaxy, and it's estimated to be 160 times larger than the Milky Way.
So that officially makes our Milky Way look like a little cosmic dust bunny.
Yeah, pretty much.
What's so special about this Alcyonius galaxy?
Well, it's fascinating because it emits these enormous jets of plasma.
What?
Yeah, they stretch like millions of light years into space.
Millions.
Millions, yeah.
Wow.
And these jets are powered by supermassive black holes at the galaxy's center.
Oh, wow.
And they emit these radio waves that astronomers can detect.
So these radio waves are like cosmic beacons,
Yeah.
signaling the presence of something massive and powerful
Exactly.
lurking at the heart of Alcyonius.
Yeah, and speaking of massive and powerful, you can't really talk about galaxies without talking about black holes, right?
Right, yeah, of course.
I always kind of imagine them as these cosmic vacuum cleaners,
I was going to say the same thing.
just sucking up everything in their path.
Yeah.
But is that really accurate?
Yeah, I don't know.
Well, it's a little more nuanced than that.
Yep.
Black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape their pull once it crosses a certain boundary,
Oh, right.
called the event horizon.
So the event horizon is like the ultimate point of no return.
You got it.
Once something crosses it, there's no coming back.
Nope.
Wow.
And as the book explains, this creates some really, bizarre effects on time itself.
Wait, time travel?
In a way. Yeah.
Is that really what we're talking about here?
Kind of, yeah.
Wow.
One of the, implications of Einstein's theory of general relativity
Right.
is that time is relative.
Okay.
It's not a constant throughout the universe.
Right.
The book uses this example of the twin paradox to illustrate how time is, affected by gravity.
I've heard of the twin paradox,
Right.
but I've never really understood it. Can you kind of break it down for me?
Sure. So imagine you have these two identical twins.
Okay.
And one twin stays on Earth,
Okay.
living their normal life,
Got it.
while the other twin hops into a spaceship
Okay.
and travels really close to a black hole
Okay.
at a speed approaching the speed of light.
Wow. Okay.
When that traveling twin returns to Earth,
Yeah.
they will have aged less than their earthbound sibling.
Wait, so the twin who went on the space adventure
Yeah.
comes back younger than the one who stayed home?
Exactly.
It's something straight out of a sci-fi movie.
I know, right? It's a mind-bending concept. But the kind of essence of the paradox is that time slows down
Oh, okay.
in stronger gravitational fields.
Interesting.
And since black holes have, immense gravity,
Right.
time flows more slowly near them compared to, regions with weaker gravity like here on Earth.
Yeah, okay, well, my brain is definitely starting to hurt a little bit.
I know, it's a lot.
But in a good way.
It is. It's fascinating stuff.
So while time might seem like this absolute unchanging thing to us here on Earth,
Yeah.
it's really not that simple.
It's not.
Time is relative,
It is.
and black holes are these cosmic time-warping wonders.
Pretty much, yeah. They really challenge our fundamental understanding of reality.
They do, they really do.
But here's a question that always kind of trips me up.
Sure.
If the universe is expanding, what is it expanding into? Is there something outside the universe?
That is a great question, and one that has puzzled scientists for a really long time.
It has.
But the book offers this helpful analogy using a balloon.
A balloon.
Yeah.
How does that relate to the universe?
Okay, so think of it like this.
Okay.
Imagine galaxies as like dots drawn on the surface of a balloon.
Okay, got it.
As you inflate the balloon, the dots move further apart, right?
Yeah, but the dots aren't moving across the surface. The
Yeah.
surface itself is expanding.
Exactly. It's not that the galaxies are like flying through space, away from each other.
Right.
It's the very fabric of space itself
Yeah.
that's stretching, and it's carrying the galaxies along for the ride.
So it's not that the universe is expanding into something else.
Right.
It's that the space between everything is growing.
Okay, that is a really helpful way to think about it.
Okay.
I can almost picture those galaxy dots spreading apart on this inflating balloon.
Exactly.
Okay, so we've covered some pretty, like, mind-blowing concepts.
Yeah, we have.
From a galaxy 160 times larger than our own to time-bending black holes and a universe that's constantly stretching.
It's a lot to take in.
What's next on our cosmic agenda?
Well, after exploring the vastness of the universe, I think it's time to tackle the ultimate question.
Which is?
Are we alone?
Now that is a question I've been waiting for.
Okay, let's get to it.
Bring on the search for extraterrestrial life. All right, so we've talked about planets and stars and even black holes.
We have.
But now for the question that's been lingering in my mind this whole time.
Shoot.
Are we alone in this vast universe?
The ultimate question, right?
It is.
And this book tackles it head on.
Okay, good.
With some thought-provoking math and some really insightful observations.
Yeah. The numbers in here about potential Earth-like planets are, like, astronomical. Literally.
Right.
Yeah.
So let's break it down.
Okay.
Just within our own Milky Way galaxy.
Okay.
Let's assume, conservatively, that each star has 10 planets.
Okay.
And let's say only half of those planets are in, like stable systems that can actually support planets, long term.
So we're narrowing down the possibilities already.
Right.
But even then, that's still a huge number of planets.
It is. And now let's say that out of those planets, only 1 in 10 has the conditions suitable for liquid water.
Right.
Which is what we consider essential for life as we know it.
Right. But even with those limitations, we're still talking about, like, billions of potentially habitable planets just within our galaxy alone.
Just in the Milky Way. And then there are trillions of galaxies out there.
Trillions. It's hard to even grasp a concept that massive.
It really is. The sheer scale of the universe makes it statistically improbable that Earth is the only place where life has taken hold.
It really makes you wonder, if there are so many potentially habitable planets out there, why haven't we found any concrete evidence of, extraterrestrial life yet? I mean, are we just looking in the wrong places? Or are our assumptions about what constitutes life too limited?
Those are great questions, and they kind of get at the heart of what's known as the Fermi paradox.
So the Fermi paradox?
Yeah, it basically points out this contradiction between the high probability of extraterrestrial life existing and the lack of any, definitive evidence for it.
Okay, so how do we even begin to, make sense of this paradox?
Well, there are a lot of theories out there,
Right.
Maybe technologically advanced civilizations tend to, destroy themselves before they even reach a point where they can travel between the stars. Or maybe they are out there, but they're intentionally staying hidden from us.
That's both fascinating and a little unsettling.
It is. It's creepy.
Like, what if they're watching us right now?
Right. I mean, who knows?
That's crazy.
But, this book brings up another really important point. Yeah. Given humanity's history of conflict and, prejudice, how would we react if we did encounter an alien civilization?
Yeah.
Would we greet them with open arms? Or would fear and misunderstanding lead to, conflict?
That's a great point. It makes you question how we would handle such a momentous event.
It does.
Would we even recognize alien life if we saw it?
Oh.
Would it be based on carbon, like us? Breathe oxygen? What if their biology is completely different from anything we can imagine?
Right. It's hard to confront, our own biases and preconceived notions.
Yeah.
When we're trying to imagine what extraterrestrial life might be like.
It really is.
It's tough.
Well, this deep dive has certainly given me a lot to think about.
Me too.
From the mind-bending physics of black holes to the tantalizing possibility of alien civilizations.
Right.
It's been quite the journey.
It's really amazing how much we can learn about the universe and our place in it.
I know.
Just by reading a book.
It really sparks our curiosity.
It does.
It makes us want to keep exploring.
For sure. That's the beauty of learning, right?
Yeah.
It always leads to more questions.
So do you think we'll ever find, definitive proof of extraterrestrial life?
I'm optimistic.
Yeah.
I am. With advancements in technology and our understanding of the universe,
right.
I think who knows what incredible discoveries await us in the future.
Well, I'm definitely adding discover evidence of alien life to my cosmic bucket list.
I like it.
This deep dive has been an incredible journey from, the tiniest particles to the vast expanse of the universe.
It has.
Thanks for guiding us through it all.
The pleasure was all mine.
And remember, everyone, the universe is always out there.
It is.
Waiting to be explored.
So keep looking up.
You got it. Until next time, keep exploring, everyone.